Hello, we are doing finding the greatest common factor. This might be something you feel very comfortable with. There's a practice for it in Schoology on Learning Target 5 that goes into Khan Academy that you can practice there. There's 7 questions, but there are 2 different ways to look at this, so we're just going to go ahead and get started. So factors are the numbers you multiply in a multiplication problem. So it's the numbers I multiply to find a product. And so an example, 4 times 3 equals 12. That is the product, and the 4 and the 3 are both factors. And you find the greatest common factor, you are finding the largest factor that 2 or more terms or numbers have in common. And I say terms instead of numbers because we are going to add in variables into that concept as well. So for instance, if I had the numbers 16 and 20, and you think of finding greatest common factors when you do fractions. You just don't even realize maybe that you're doing that anymore. But I know I could divide them both by 2 because they are even numbers. But there's something bigger, the greatest common factor that they have. So 2 is a common factor, but 4 is the greatest common factor to get my fraction to its simplest terms. So you're used to doing it in that form, and now we're just going to be doing it just slightly in a different format, but we're doing the exact same thing. So for instance, the factors of 14, I've got 1 times 14 and 2 times 7. And the factors of 28 are 1 and 28 and 2 and 14 and 4 and 7. So once again, they have 2 in common, but 7 is something that they also have in common. So the greatest common factor is 7. So the common factors are 1, 2, and 7, and 14. In fact, sorry, 7 is not the greatest. 14 is indeed the greatest there. Small brain fart. Sorry about that, friends. So if you look down at these, you can do that same thing. You can make the list of factors. And 1, 2, 7, and 14, and 1, 2, 4, 5, 10, and 20 here. The biggest one they're going to have in common is 2. This next one, 16, I've got 1 and 16, and 2, and 8, and 4. And I've got 1, and 42, and 2, and 21, and 3, and 14, and 6 and 7, do all that work and realize that the greatest one again is 2. Two is not always the greatest common factor, as you can tell from if there was 14. So this one right here biggest one they have in common is 12. And the greatest common factor we have here is 15. So that is one way to find the greatest common factor, or in fact all the common factors that they have. Another way to do it is by doing a factor tree. And so when we do prime factorization and make a factor tree, we know that 2 is actually the first prime number, which sounds odd because it's an even number, but it is our first prime number. And then we've got 2, we've got 3, we've got 5, 7, 11, 13, 17. So these are all prime factors as you get into larger numbers that you might see. So if I divide 14 by 2, I get 7, which is also prime. When I do 28, I get 2 times 14, but that can be broken down as well into 2 and 7. And that's just bringing that down there. So we've got 2 times 7 and 2 times 2 times 7, which could also be written as 2 squared times 7, just for future reference. The common factors that they have are 2 and the 7, so 2 times 7 is 14, which probably would have been helpful on the last page for me, huh? So our greatest common factor there is 14. Now in class we then played with some bigger numbers to try to challenge ourselves. We can do the same thing with 18 here, 2 and 9, 3 and 3, so 2 times 3 squared, 2 and 15, 3 and 5, so those are all prime, so 2 times 3 times 5. So you can think of that as 2 times 3 squared, or 2 times 3 times 3. I've got the 2 and the 3 in common, so 2 times 3 is 6. So the greatest common factor there is 6. Sorry, that is a 3. 60 and 45. I've got 2 and 30. And then can I go by 2 again? And I can. 2 and 15. And these 2's are prime, so I know that's like the end of the line. And then 15 is 3 and 5. So 2 times 2 times 3 times 5. 45, I can't do 2, but I can do 3. So 3 times 3 times 5. So I know that their greatest common factor is 15. Moving on from that, we did some practice with when variables get involved. So if I'm finding a greatest common factor and variables are involved, I need to take care of that number part first. If I know my multiplication facts, it makes it a whole lot easier. So I look at these and I can say, well, I know I can divide them both by 2 and I can't get bigger than that, so 2 is going to be the number. Now I need to see what variables they have in common. They both have an x to the first degree in common, so I know I could take that out. And what we're kind of bridging to is, could I do 8x, could I divide it by 2x? Well, yes, the x's would cancel out and that would give me 4. My 10xy divided by 2x, that cancels out. I still have the y. 10 divided by 2 is 5. So I'm like, what can I divide these both by? And then when I get there, it's like in my simplest forms. There's nothing else I could divide them both by. 12 and 16. And 2 works. And I say, can I go bigger? Well, I can go 4. Then I've got an x and an x squared. So I could take an x out of both of them. They don't both have a y. But I think later of 12x, the x's cancel out. 12 divided by 4 is 3, so that would simplify to 3y. And 16x squared, when I divide that by 4x, this is like x times x. So I'm only losing one of them, so I still have one of the x's left. And then 16 divided by 4 is 4. So that would be what I would have left over, because we're eventually going to be doing this with expressions. So I want you to know this is why we're trying to find that greatest common factor. If I end up and I don't find the greatest common factor by accident, when I do this division, they'll still have something in common. I'm like, oh, I could have included that over there. So over here we have negative 15 and negative 12. If both of my terms are negative, I want to pull out a negative number. And in this case, I can pull out a negative 3 from both of them. They also both have an a in common. So for instance, if I did negative 15 divided by negative 3a, the a's cancel out. I still have my b and my c. Negative 15 divided by negative 3 will give me a 5. Negative 12AD divided by negative 3A. The A cancels out. I still have the d left, and negative 12 divided by negative 3 is 4. So still they have nothing in common. We're good. Going down here, I've got 3 different numbers. Only one of them's negative. So I'm not going to pull out a negative. I'm going to pull out whatever positive number is their greatest common factor. So if I look at these, I know I can't divide them all by 2. I can divide them all by 3. 5 doesn't work. 6 doesn't work. 8 doesn't work. 7 doesn't work. So I think 3 is going to be our greatest common factor in terms of numbers. Once again, I'm going to keep it positive. Now they all have at least one A, and they all have at least one C. So this is going to be my greatest common factor. When I go into thinking about that next step, 15ABC divided by 3AC, it would simplify it down to that if I were to divide it by that. My negative 24a squared c squared, only one of those is going to cancel out, and both of those, so I'll still have an a and a c left with a negative 8, and 18a squared b cubed c divided by 3ac. Once again, only one of those is going to cancel out. Those will completely cancel out, and I'll get 6a b to the third power. So that's what we're going to be ramping up into with our next part of this tomorrow. So, but it just kind of gives you an idea, like, why would we do this, and how can I check to see, did I do it correctly? And so I can see here, like, these both still have an a, but because I have that third one without an a, I can't take another a out and make that an a squared. And you'll run into that with your homework tonight. On this problem right here, I can take out something bigger than just an a. So as a challenge to you, what could you take out there? Hopefully this has been helpful. Let me know if you have any questions.